So far in this class, we have discussed about what is demand forecasting. We have spoken about the what is the need of working on demand forecasting. We have discussed about what are the different source of having and data for forecasting. Either they are based on primary data or secondary data. We have spoken about different kinds of forecasting mechanism. Either it can be short run forecasting or medium range or long run forecasting depending upon the product, depending upon their shelf life. We have discussed about what are the different steps in forecasting. Then last class we have analyzed the methods of doing forecasting. We have done qualitative methods, and now in this class we'll talk about quantitative method. So basically the quantitative method what we are talking about here now, this method is based on time series analysis. Okay, so talking about the methods, more or less, the method names are given here. Two method names are given here. One is casual or regression analysis, and the next one is time series analysis. But if you go statistically, uh, both mean same thing because time series comes under regression only. When what is regression? Regression is the mathematical technique where we study the relationship between two variable, where one variable is dependent on the other variable. So the variable which is independent here is the time period. Okay, and the dependent variable can be anything. It can be your production, it can be your sales, it can be revenue, anything like that. So we when we study these methods, we are trying to study everything in the perspective of time. Okay, first I'll give you an idea about casual method. Casual method is expressed as you can see in the equation like dt is equal to f. F basically means function of. So basically what they are telling you in this equation, they are trying to say that the demand for the given time is dependent on different factors. Those factors they have mentioned, it can be sales budget, it can be pricing, it can be proportional budgeting, it can be technology, it can be different factors they have mentioned. And when it comes to your demand for your product, it depend on these methods. Okay, that is what they are trying to say. So you don't have to memorize sales budget. This is not some mathematical formula. They have just given you an idea that demand is based on many parameters. Now demand is based on many parameters, and if I bring mathematically those parameters cannot be limited parameters. But if I try to bring the real life situations in the form of mathematical formulas, then there can be some parameters. Those parameters I have tried to put it here. It can be sales budget, it can be pricing, it can be promotional budget, it can be technology. Okay, and here we need to take the account of time. Okay, account because time is everything, because we are talking everything in the perspective of the time only. So the casual method consider how multiple variables, they can be sales budget, price, promotional budget, technology, they influence the demand together. For example, higher price may reduce the demand, but while more promotion may increase it. So different parameters, they have different relation with the demand, and rise in one parameter can affect the demand in other way. It can be like directly proportional, or it can be inversely proportional. Okay, so think of it like this: the demand does not change by itself, it changes because of the other reasons or the causes, and that's why we call this the casual method. So you can say that like you can give an idea like the company try to find out how different factors influences the demand. For example, there is a company which is trying to find out what are the factors which ultimately affect the demand. It can be sales budget. If the company spend more on selling effort, demand definitely will increase. It can be pricing. If the prices goes up, then definitely the people will buy less. Promotional budget, maybe if the company do more promotion, more advertisement, then this will attract the customer and the demand will shoot up. Then it can be technology. So better technology can make the product more attractive or cheaper, increasing the demand. Okay, so basically in order to work on this demand forecasting, basically we have to do mathematical analysis. And in order to do this mathematical analysis, past data or historical data is required, related to pricing, relating to promotional budgeting, relating to technology, and looking on these past data and how these past data either affecting your demand positively or negatively. That has to be worked on in the form of some mathematical formula, and then only it will help us to predict the future demand. Okay, for example, like already I have given the example that when the price become more, sales will come down. When advertising will increase, the sales will went up. When new technologies are added, then sales will end up. So in casual methods, we can say that the demand depends on different factors, either price, promotion, sales, efforts, technology. And if we know how these causes affect the demand, we can predict the future sales more accurately. Okay, but sometime you know that the sometimes the cases like COVID and all, when it has happened, and when the COVID issue has happened and all, so you understand, then these kind of mathematical model may not work during that time, because when we are talking about casual method or regression method or time series method, all are based on mathematical data, and that mathematical data is based on certain parameters, and nobody can account the parameter of like some events like COVID or unexpectedness events. And when these kind of event happen, definitely your all mathematical calculation will settle down. Okay, so sometimes like this model misses sudden changes in market behavior due to COVID-19 pandemic. For example, the company forecasting demand in 2020 might have surprised by drastic change caused by pandemic. I hope you're getting it. Okay, so you have to understand that the forecasting is never 100% accurate. There's always some error uh, in the predicted and the actual result. And this inaccuracy is better understood by using time series analysis. Okay, so when we talk about time series analysis, we basically account of basically four parameters, four component. One is trend, another one is seasonality, third one is cyclical, fourth one is irregular. So when we do time series analysis, there we account the parameter that your time, your demand based on time is basically dependent on some parameters. Those parameters are basically those four parameters are there. Like some product behave with respect to time in different ways. Some product follow a trend, like in stock market and all, we do technical analysis, and technical analysis is all about following a trend. Okay, there we always try to find the trend, like your stock or whatever, what kind of trend it is following. Is it in uptrend or it is in downtrend? If the stock is in uptrend, then it will go up like that. If a downtrend, it would fall down. So trend we can find for those kind of components which follow a pattern. If they follow a pattern, we can follow the trend. Okay, if sometimes there are many products are there, they don't follow any pattern, and they follow random movement. So those things we study in the irregular or random behavior. Then we have some kind of product will follow a cyclical pattern. Cyclical pattern means their demand goes up and goes down with the time. In the time means like maybe you can talk about ice cream, or maybe you can talk about sales of cold drinks and all. So sales of cold drink and all, every year it will boost up during the summer season, and then it will fall down in winter season. Again, it will boost up in summer season. So it's like they're following a cyclical pattern. Seasonality is similar to cyclical, but seasonality is like a shorter form of cyclical, where the cyclical movement, if it happen within a month or within a 2 month like that, then it would call a seasonality. Maybe you can say that the sale of alcohol or beverages increases in weekend, and weekday there's no as such sales. And that lot of pubs and resto bars are there in Bangalore. Weekend there's huge rush, but in weekday there's no rush. So seasonality is a shorter form of cyclicality, but seasonality is something which is repeating in very shorter time period. So here, when we talk about time series analysis, we are talking about trend which shows the long-term direction of data upward, downward, or stable over the time. When we talk about seasonality, it's talking about it representing a regular and repeating pattern within the year. I give you an example. Seasonality and cyclicity is same thing. Seasonality is the similar behavior, but the time period would be lesser. So seasonality represent the regular and repeating pattern within the year. Example, higher sales of air conditioner in summer or festival season shopping spike. Like example of seasonality can be if you want the repair of AC, that will happen mostly in summer season, and during Diwali or Dashera they would be very high in sales. Cyclical behavior refers to long-term cycle that last more than a year, usually linked to economic or business cycle. Example, phase of prosperity, recession, depression, recovery. Cyclical is basically something same kind of pattern which is repeating, but it might that pattern follow more than a year. Like in economics, we study like sometimes your economy is in hyperinflation mode, your economy is in recession mode, your economy is in recovery mode and all. And yesterday night only the Federal Reserve Jerome Powell has reduced the interest rate in US, and that way it looks like the market will become positive. Okay, more or less the market was anticipating a 25 basis point change in the interest rate, and that is what happened. And they have given a negative warning stating that no more they will change the interest rate because US is struggling with the economic process. So cyclicity is something which you connect more with the economic phase of recession, depression, hyperinflation, or recovery, or any kind of behavior. Then it is called a cyclicity or cyclical variation. So basically, there are four components of time series data. It can be trend, it can be seasonality, it can be cyclical variation, it can be random variation. Random variation is something which is random, which you cannot follow by using any kind of mathematical model. Getting it, guys? Any doubt?
Yes, sir. Got it.
Okay, 1 minute. Basically, the time series model, what we study, there are of two type. They can be additive model or they can be multiplicative model. So additive models basically means T stand for trend, S stand for seasonality, C stand for cyclical, I stand for irregular. So when we are talking about additive model, we what we are trying to say that these all four components you are getting it by the addition form. Basically addition and multiplication, how you can make it different. Addition basically means you are considering one parameter at time. So basically when you are talking about additive model, it means whatever the parameter you are studying, it is following either trend, either seasonality, either it is irregular, either it is cyclical. It is not like it is happening together. If everything happening together, then you are studying a multiplicative model where you are multiplying. Okay, like if I give you an example, that from Bangalore to Mysore, I can go by 4 trains and I can come back by 3 trains. So in how many ways can I go to Bangalore to Mysore and come back? The answer would be 4 into 3, 12. Okay, because you are going by one train, coming back by another train. Okay, so if you start counting it, it would be like 12. If I say I have 4 shirts and 5 pants, so in how many ways I can wear them? I can wear them in 20 ways, because one shirt, first pant, one first shirt, second pant, first shirt, third pant, first shirt, fourth pant, second shirt, first pant, second shirt, second pant. So what you are trying to say that if the events can be done together, then it is called as multiplicative model. Okay, additive model means if I say that I have 4 shirts and I have 5 t-shirts. So in how many ways can I wear them? I can wear them in 9 ways. I cannot wear shirts and t-shirt together. So when you can do it together, it is multiplication. When you are doing one behavior at a time, when you are studying any kind of situation, any kind of model where you can study only one parameter at time, then it is an additive model. Here, most probably we use this equation. This is the equation of linear line where we use the equation called y equal to a plus bt. So a and b are the coefficients. Okay, so b is called the slope of the line. This is the relation. This is the relation when two behavior are linear connected. Linear मतलब क्या होता है? Straight line. If you're studying any kind of mathematical model where if you're like these all you have studied in, these all is a mathematical for studying for regression also in statistics. You studied regression and all in statistics. So basically when you are trying to study the behavior where the relationship, suppose if that is straight line relationship, it is called linear relationship. So the every linear relationship follow this equation, y is equal to a plus bx, where y is equal to a plus bx. B basically means slope. So what is slope and all? If you don't know in mathematics, slope is basically the angle. Slope is basically your angle, the angle what the line makes with the your horizontal axis. So that is called slope. That slope in, if you remember, if you have done mathematics in PU, in coordinate geometry and all, basically we study this with the formula y2 minus y1 by x2 minus x1, all that is there. Formula of slope. You can ignore that, but just remember this is the uh, remember that basically the y is equal to bx. Basically here b is basically the slope of the regression line, which where if when you see this equation, where when you are seeing this equation you are getting a relationship between two variable. What are the two variables you are getting? What are the two variable? This is the independent variable called x, and this is a dependent variable called y, where we are trying to say how x is, sorry, how y is dependent on x, because y is the dependent variable. So how your dependent variable is dependent on independent variable called x, that we are studying here. So more or less whenever we'll study the time series analysis, we are trying to study the relationship between two variable where one variable is dependent on the other variable. So the relationship what we are studying here, we will focus more on linear relationship. Linear relationship is the most easy relationship to study. Linear relationship is which is a straight line relationship, and whenever we study straight line relationship, basically in straight line relationship we'll follow this equation, y is equal to a plus bx. And so when we have a straight line relationship, the relationship can be found out very easily. Okay. Then the relationship can be parabolic, quadratic equation. You have studied in maths and all. Linear, quadratic, which is in this form. Y equal to quadratic is like something like this. Parabolic. When we study quadratic is something which is parabolic, and it will follow a parabola. So whenever it's a quadratic relationship, then the higher coefficient would be 2. Like you can see this is parabolic relationship. And so it can be either exponential relationship, and this can be either exponential relationship, but we'll focus more on linear relationship only. We'll focus more on linear relationship only. Will not try to gather mode analysis either in parabolic or exponential and all. If you are not understanding this, what they have done, what we have done, y equal to a plus, if I write it here, y is equal to, if it exponential relationship, y is equal to a into b to the power t. Suppose many people are not good with basic maths. So if you want to study this exponential relationship, so you studied in log. And log, what log basically do? Why we are multiplying with log? Because whenever you multiply any number with log and you have the power, log will make the power to come in numerator. So so this is, you will get log a So log y is equal to log a plus the t is in power. So it become t into log b. Basically, when we study log, log always have a base. If base is not defined, then we'll take the base as 10. Because here, if you are not writing the base, means your base is 10. Okay, so that is what is written here. So log y is equal to ab to the power t, and if you multiply log here, you are getting log yt is equal to log a plus t log b. So these are basically what we are trying to do. We are trying to focus more on mathematical relationship. The relationship of trend can be uh, either it can be secular trend, and when we are studying secular trend, we are talking about relationship. Either it can be linear, it can be parabolic, or it can be exponential, and then this will help us to model the behavior here. So I hope you are understanding this, right? Y is equal to a plus bt. So basically, time series analysis, what is doing, it is helping us in understanding how your demand or supply is changing over the time, and there we are, what we are trying to do, we are trying to find the trend. Okay, we are trying to find the trend, and there we studied the relationship of the trend. Either it can be linear, it can be parabolic. Parabolic basically means, when you study parabolic, what do you mean by parabolic and all? Parabolic basically means the type of trend which is used when data does not increase or decrease evenly. The curve shows that the rate of change itself changes. For example, in the beginning, maybe the sales is going slow. Later, it becomes fast, and after some time, it becomes slow. Then you are getting parabolic trend. Okay, so it is like slow, fast, slow pattern over the time. Exponential trend, it is used when the data increases or decreases rapidly over the time. For example, during fast growth or decline. Maybe if you are studying some kind of bacterial or parabolic, not para means parabolic, parabola nahi, bacterial or virus kind of growth pattern, or in COVID time, how the disease spread. It does not spread in arithmetic progression. It is spread in geometric progression. So exponential trend is basically used when your data increases or decreases rapidly over the time. Oh, during, for example, during fast growth or decline time period. Okay, so that there we study something called exponential parameters. This is common in technology, population growth, or viral product sales. Okay, so whenever guys, we are talking about what you say, time series analysis, we are trying to forecast the demand by working on different models. Models can be your casual or regression model, or it can be time series model and all. You know that whenever we are trying to predict the demand, okay, and you know that it may not be the actual demand, because I hope you are getting it, guys, because you, whenever you study demand forecasting and all, you are predicting the demand. Let the demand which is predicted is something like this, and you are trying to predict the demand, and let this is my predicted demand as per my mathematical calculation and analysis. Suppose this is the demand which I have predicted, but in reality your real demand may not be equal to the predicted demand. And suppose this is your real demand, YT. So your real demand would be equal to your predicted demand plus error possibility, because you cannot be 100% correct. They can be difference between the predicted demand and the actual demand, and we'll call the difference as an error. And whenever we try to measure how accurate our forecast is using different methods, okay, then the difference we'll measure with the term called MAC here. MAC basically is the mean square error. Okay, that error what we are getting, okay, that error what we are getting, the difference between predicted demand and actual demand, that we are trying to measure with a mathematical term called error. And that error, when we are trying to study, if the error is small, then your forecast would be accurate. And if we have larger error, then your forecast is not reliable. Okay, so smaller the error, better would be the model. Getting it, guys?
Yes, sir.
So here everything we are studying in additive model only, where your error is nothing but the difference between your actual demand and the predicted demand. And if we study the standard deviation of the error, okay, because the error, when we having the data of the error, and if we try to find the standard deviation of that, basically then we are getting a mathematical figure called mean square error. And if this figure is less, then it would be, then it's like we are good with the methods what we are using. But if there's too much deviation is coming, then we not be very sure about the kind of methods we are using. Okay, so basically once we remove the trend from the data, what remain in the data is basically your seasonal and irregular variation. And then we need to find the seasonal pattern like regular increase in sales during festival or summer month. And there can be different methods when it comes to trend. Okay, so when I talked about time series analysis and all, when I talked about time series analysis, I have given you four parameters. One is trend, the other one is seasonality, other one is cyclicity, cyclical or irregular. So to measure the trend, here we talked about whenever we have the possibility of trend, we talked about linear relationship. This is quadratic, sorry, this is quadratic or parabolic. Then we have studied about linear relationship, we have studied about quadratic relationship, we have studied about exponential relationship. And then when we are trying to study the seasonal variation, then we have methods like method based on moving average, we have method based on weightage moving average, then we have simple exponential smoothing method, we have double exponential smoothing method, we have another method called hot winter model method. Basically, these methods, what I'm talking about, your moving average or weightage moving average or simple moving average or double exponential smoothing method, all these methods, whatever I'm talking about, these methods, what they will do, they'll help us to calculate the seasonal variation. Okay, seasonal variation. Basically, when we are trying to study the seasonal variation, we have this method. First method, which we is the moving average. And when we talk about moving average and all, what moving average method it do, it takes the average of the few time period like 3 month or 1 year, to smooth out the short ups and down. Basically what we are doing in moving average method and all, we take the data, the historical data is being taken, and then what we do, we take the average. You know the formula of average. Average is the total sum of data by the number of data, like, and like in stock market also will we use average and moving averages we use, and a simple moving average, exponential moving average and all. Like 10-day moving average, 10-day moving average means you will take the data of 10 day and then you total add the 10-day data divided by 10, so you'll get the 10-day moving average. So basically if you are using moving average method, it takes the average of few time period data, maybe 3 month or 6 month or 1 year, and then we'll find out the average of the data. The objective is to somehow figure out some kind of trend you are getting on the data and all. So some kind of mechanism we are trying to use here, okay, to make sure that we can do the averaging of the data. The advantage of autumn moving average is the simplicity in computation. However, it has to forego end period in the beginning and the end. Hence, it loses some fluctuation and applicable for long period. For longer period, possibility of error always increases. Another limitation is that odd term moving average is one time average calculation method here. Basically, whenever you find the moving average and all, it can be odd term or it can be even term. Odd term, like imagine your data is like 2n plus 1. So imagine if your data is 2n plus 1, okay, or it can be even term, maybe 2n. Okay, we'll do numericals. Based on this, we'll get more idea about this. So like some data is like this. So year wise data, then we bifurcated quarter wise, each year different quarter. Then for each quarter, there's different sales are there. And then what we are trying to do, we are trying to find the either trend or seasonality or seasonal index. Okay, here basically the equation what we'll follow, the equation what we are following is this equation only, y equal to a plus bx. We are following this equation only, y equal to, we'll follow the equation called y is equal to a plus bx will follow, where a and b are your constant, where y is equal to a plus bx. Now to get the value of this constant, now to get the value of these two constant, we will follow this mathematical relationship. So first is sum of y is equal to na plus b sum of t, and the next equation for linear relationship will follow is sum of ty is equal to a sum of t plus b sum of t square. So these are the two equation will follow. Okay, so basically, I write down these two equation. So now to get the value, because here you have two constants are there, a and b. Now to get the value of these two constants, we'll have two equations. When we'll do numerical, you'll get more clarity. So we have two constants, a and b. Now to get the value of the this a and b, will follow the two equations. Sum of y is equal to na plus b sum of x, or the t or x, I can say that independent variable can be time or it can be x. So if I'm using here, so the t, then its equation is sum of y is equal to na plus b sum of x, and here I can say sum of y into t is equal to a sum of x plus b sum of x square or t square. You can write down these two equation somewhere. Okay, these three equation, write it down. Y is equal to a plus bx. We'll use these three equation. First equation is y is equal to a plus bx. Second equation is this equation, sum of yt is equal to na plus sum of b sum of t. So I'll use sometime t word, sometime I'll use x. Please understand both are same thing. Both represent your independent variable, and this is your third equation. Clear na everyone?
Yes, sir.
And please write down these two equations, because when we are solving the problem, we'll use these three equations, because I'm not able to write here properly. That's why I'm just dictating you to write down this equation. Okay, so we'll use three equation, and what would be our end objective while doing the numerical? We'll try to make this sum of t zero. We'll try to make this sum of t zero. If we make sum of t zero, then your value of a would be sum of y by n. If you're getting it, like if I write here sum of y, if I write sum of y is equal to sum of y is equal to na na plus b sum of x. And imagine if I make my sum of x 0. Suppose if I make this 0, if this becomes 0, then whole will become 0, correct? Then what would be the a value? Your a value, your a value would be sum of y by n, correct?
Yes, sir.
है ना? Then similarly in the second equation, if you see in this equation, again if your sum of t become 0, then what is your b value? Okay, a तो ये पूरा 0 हो जाएगा, this all will become 0. Your b value would be sum of ty divide by sum of t square. That is what is written in the time series. If you make sum of t 0, then your a value would be sum of y by n, and your b value, and here your b value would be sum of ty by sum of t square. So then if we get the a and b value easily, once we get this a and b value easily, we'll put this a and b value, we'll put this a and b value into this equation, y is equal to a plus bt, and we'll get the equation of the straight line. Okay, very simple. We'll do some example. If I show you, you'll get more idea. See this question. From the following times is data of the sales, project the sales for next 3 years. This is the question. Okay, everyone.
Okay, sir.
Okay. So you have this. Let me open in Excel. So different year is given. 15 say 21, 2015, and 2016, 2017, 2018, 2019, 2020, 2021. These are the year. Then you have sales in thousand. Sales in thousand is 80, 90, then 92, then 83. Then you have 94, 99, 94, 99, and then you have 92. Okay. So what we do, guys, यहाँ पे what I'll do, how many years are there? How many years are there? Vandu,
7.
Erudu, Muru, Nalku. Total 7 are there. So what you do, figure out the middle year, because odd data is there, so you can find out the middle data very easily. Can I write an equation here called T is equal to year minus 2018? Are you getting me? And then I'll find this variable T. So what would be your T? T would be minus 3, minus 2, minus 1, 0, 1, 2, 3. Getting it, everyone?
Yes, sir.
So, and then what I'll do, I can find T square. T square मतलब 3 minus 3 square 9, 4, 1, 0, 1, 4, 9. Okay, and I can find this. तो year को I am representing sales. Can I represent with y? So if then I can find this y into t as 80. 80 into minus 3 would be minus. Okay, 80 into minus 3 would be minus 240, like this. Okay, everyone. So what is the sum of this? 56. And what is the sum of this? 630. Okay, so this is what is done here. Can you see? Here n is 7, so you can find easily the middlemost value. So this they represent with x, there they are representing with t. So I thought they are representing there with t, so I use the symbol t, but here they use the symbol x. I hope you will not mind using any symbol, x or t, whatever you can symbol you can use. And then sales they represented with y. This is the total sum of sales, 630, and then they did the square of x. You get 28, 28, and then the product of time deviation and sales you get is 56. Is this clear?
Yes, sir.
and that this is the regression equation y is equal to a plus bx. Now what I did guys, I made the time zero. What I did guys, I made this zero, this time zero, and then we have this equation. We have this equation here pe I made this time zero. I made this time. This is zero. I made this zero. Then what is my a? A is nothing but sum of y by n. Sum of y क्या है? Sum of y is 630. So what is my a? My a would be 630 by n. What is n? N is 7. This would be 90. So this is the formula guys. This is the this is the this is your formula. This is your formula. This is what is your formula? This is your formula. Now in this formula you have two variable a and b. अब क्या होता है मैथ्स में, if you understand maths and all, if you have two variable, you need two equation, then you only have to solve both the equation together to get the value of a and b if you're getting two simultaneous linear equation and all. But what we did, somehow we made the sum of x zero. Sum of x zero कैसे किया मैंने? मैंने क्या किया, I just took the middle most year out of these year, and then I just hypothetically use one mathematical term variable जहाँ पे middle most year I subtracted from all the year, and that I am presenting as x or t. So अगर मेरा sum of t or sum of x become zero here, then my a would be sum of y by n. Is this clear?
Yes, sir.
And then what is your b? What is your b here? What is your, this is your a. And then what is your b? B is nothing but sum of xy by sum of x square. So sum of xy is 56 and sum of x square is 28. So you got the b. B is 2. Your b is 2. Your a is 90. Okay. So once you get, how you got the b value? How you got the b value? How you got the b value? If you remember the equation, if you remember the equation, this is parabolic and all. If you remember the equation, this was the equation. यहाँ पे मैंने क्या किया? What we did, we made the sum of t zero. So if the sum of t is zero, then this will become zero. Then what is your b? B is nothing but sum of xy by sum of x square. This is what we did. So what is b? Your b is nothing but sum of xy, which is 56, divided by sum of x square or t square. This is nothing but 2. So once you get this, you got, then your equation is y is equal to a plus bx. So what is y? Y is equal to a. What is a? A is 90 plus b is 2, and this is x or t, whatever. Then guys, what is y? Y is 90 plus 2. What is x basically? What is x or t basically? It is basically year minus 2018. It is basically year minus 2018. This is basically your equation. Then what they ask you here, here they asking you, okay, find the sales of next 3 years. Find the sales of next 3 year. Next 3 year मतलब 2022, 23, 24. So next 3 years are what? 2022, 2023, 2024. So what is the sales of 2022? It is 90 plus 2 into what is your year? 2022 minus 2018. So this is the sales of 2022. What is the sales of 2023? 90 plus 2 into year. Year is 2023 minus 2018. This is the sales of 2023. What is the sales of 2024? 90 plus 2 into Year is 2024 minus 2018. You got the sales of 2024. Clear? Means these all are in thousands. These figures are in thousand units. So all these are, this is 98,000 units. This is 10, then 00 units. This is 10200 units. These are the sales in next 3 years. These are the sales for next 3 years. Clear?
Yes, sir.
ठीक है, we'll do more numericals tomorrow. So this much we are doing today. I hope you have understood what all we have done. I'll send you the recording. You go through the recording, you'll understand. These are very basic mathematical equations. These all you have studied in PU and all. Otherwise, for revision, again, you are studying statistics in this semester in your college. These all will be taught to you. The least square method. This is called least square method in time series analysis. You will study this. In MBA also, one numericals 100% come Bangalore City based on least square method. So don't worry, you'll study this for next 3 4 years. You're gonna study these things. Okay, everyone.
Okay, sir.